All right. Hello, can you hear me, guys? If you can hear me, let me see in the chat box. Just drop a yes in the chat box. Let me see if you can hear me. All right. All right. So let's get started. I hope my screen is visible now. All right, so today we are going to talk about data visualization, which is one of the most important components when it comes to data analysis and data science as a whole. Um, there are a lot of libraries that you can use for this kind of purpose. For today, we will talk about two of them, which is Matplotlib and Seaborn. But data visualization is its own domain that people actually specialize in it because you can do all the analysis, you can do all the data munching and everything, you can get your data and everything. But how you communicate it with the stakeholders is one of the important components when it comes to data analysis and data science as a whole. Guys, can you confirm for me if my screen is still visible? All right, so as I was saying, data visualization itself is a whole domain that people concentrate. So you can just pick that domain, specialize in that domain, and it's a whole, a whole career altogether. All right. So today we'll talk about some of the libraries that you can use when it comes to data visualization, and what we'll concentrate most on is Matplotlib and Seaborn. All right. Yes, this session is being recorded. Thank you for reminding me for that. So Matplotlib is quite popular when it comes to visualization in Python, simply because most of the other, who is giving me feedback here, simply because most of the other libraries are built on Matplotlib, and it's quite easy to integrate with other libraries, all right? If your mic is on, please mute yourself because you give me feedback here, which is very bad. All right, so as we started with NumPy and Pandas and all the other topics that we've been dealing so far, what we do at first is load our library. And the same here, Matplotlib is another library that we will deal with. Before we move on to Seaborn, we would like to explore a little bit with Matplotlib before we talk about Seaborn and see the functions of Seaborn and how Seaborn is being preferred as compared to other libraries. So let's get started straight away by starting to load our libraries. So last week we talked about NumPy. So if you see over here, You see over here, we have NumPy here. We've imported our NumPy, and then we have pandas here. All right. So these are the two libraries we've already dealt with for our previous sessions. And today we will talk about this third one here, which is matplotlib.pyplot as PLT. All right. PLT is just a short form of the matplotlib because we don't want to be typing matplotlib.pyplot over and over again. All right. So we will just shorten it to PLT. Okay. So moving forward, we will be using only PLT and not matplotlib.pyplot. We will not be typing it over and over again. We will just use PLT. All right. And then we have this one here, which is not quite familiar to us. We've not been using this here, right? This is just to help us being able to plot our graphs inside the Jupyter notebook, all right? Just a way of helping us to plot our graph inside our Jupyter notebook, okay? We are going to use the plot function, and if you want to know more about the plot function and the kind of arguments that you can use, then you will comment this when you get access to the notebook. You will comment this, and when you run this, you see that there's a lot of explanations that will come with it over here. All right, so a lot of explanations that will come over here. You see the plt.plots, and then you see the arguments that you can use over here, right? All the arguments and the explanations will come over here. All right. So I've put that one for you here, just in case you want to explore more about that. All right. So let me get that one over. So quickly, let's start. Let's start to plot something. So we are going to plot just a dot. All right. We are going to plot just a dot. From last week's video, we've been dealing with pandas data frame and NumPy, but we have not been doing any plotting, but today we'll be doing plotting. All right. So let's just try and then plot this dot. All right. So we are saying that on the x-axis, we want on the 0.4, right, on the x-axis, and then 0.3 on the y-axis. We plot this dot there at their coordinates, right? So when we run it, we see that we have our results here, right? We have the dot being plotted there. On the x-axis, you can see that 4 is here, right? As we can see over here. I think I have to mute everyone. Someone's microphone is on and disturbing me. All right. So you can see that our dot has been plotted, right? And we are using matplotlib here, right? If you can see, we are using the PLT. We imported matplotlib.pyplot as PLT, and we are using PLT here, all right? We are using PLT.plot. Okay, we are using PLT.plot to plot this. And this number is just the x coordinates, and this 3 is just the y coordinates, right? You can see y here, and then the x plotting this dot. All right. So let's try and then plot something more interesting. Let's plot several points. All right. So over here, if you remember the NumPy class, we talk about the NumPy array, right? The same thing we are doing here, nothing different. The same thing we are doing here. So we have our list here, list of numbers, and then we are using the NumPy array, all right, to convert this list into an array. Okay. Then after that, this is the x what do you call it? X coordinates, right? Just as we have here, we are having only one, right? Only one x coordinates and then only one y coordinate here. But here we are generating more than one. Okay, that's why we have a list here. And then the y coordinate is just the s coordinate divided by 2. Okay, we are picking each one of them. Like if you pick 2, we divide it by 2, right? If you pick 4, we divide it by 2, right? This is what we are doing to get the x coordinates, right? So if we run that, you see that we have our nice graph here. We have several points. being plotted, right? There's several points being plotted. So when x equals 2, y equals 1. When x equals 4, y equals 2. When x equals 6, y equals 3. All right, that's what is happening here. We can also label the axis, right? Like here is x-axis, but it's nothing there. If you see the y-axis, there's nothing there. We can label it manually, all right? And in doing so, this is what we're going to use to do that, right? We're going to use plt.y label and then plt.x label. For y label, we are using the y label for the y coordinate to label the y-axis, all right? And then we are using the x label to label the x-axis, all right? Then we are using the plt.show to plot, show our graph, okay? So if we run this, we have our line there, right? But now you can see that we have a label. We have a y-axis because we name it y-axis over there. Then we have x-axis, all right? This name is just a name that we chose, right? We can just name it maybe, let's name it horizontal, all right? And then let's name, no, let's name this one vertical rather. And then name this one horizontal. Okay, so when we run this, now you can see that we have vertical and then horizontal. So we can name the axis manually. Okay. Now let's try and then plot multiple plots, right? So we are continuously increasing it, right? Making it a bit complex. Because on the normal circumstance, that's what you're going to do. You're not going to plot just a single point like this or just ordinary points like this. You're going to plot complex graphs, right? So let's try that and then see. So here we are having our list and then list of class from class 1 to class 7. All right, from class 1 to class 7. And then we are storing it in a variable called names. Okay, and then we are having our scores from 10 to 100. All right, so class 1 is having a score of 10. Then class 2 is having a score of 15. Class 3 is having a score of 20. Class 4 is having a score of 30, right? The same thing all the way to class 7, having a score of 100. Okay, now if you see this part, right, we have PLT dot figure, and then the figure size is 20 by 10, right? What this one is doing, this, let me show you the graph so that you can see. What is doing is that we are setting a figure size, right? And we are saying that the length is supposed to be 20, right? And then the width is supposed to be 10, right? So if you see it here, from here all the way down here, right? You see that down here is longer, right? It's like a rectangle, 20, and then the vertical part is 10, right? The vertical part is 10, and then the horizontal is 20. Now we have another one here that you can take note of here. plt.subplot. Subplots is helping us to plot more than one plot, right? It's helping us to plot subplots, right? Not just one plot like we did over here, right? We want to plot different plots and then be able to visualize it and then compare it and see how each plot is doing, right? So that's what subplot is helping us to do, to plot more than one plot at the same time, right? So that's what subplot is helping us to do. Now with this number that I've put here, right? The first number here, we are seeing 131, right? In subplot, we are seeing 131 in the argument or parameter, right? What it's doing is that the first one, this one, which is at last here, is showing the position 1 for this plot that we see here, for this bar graph that we see here, right? And it's saying that we have at the first position, right? I've actually written the explanation down here for you. I've written the explanation down here for you. So if you see it down here, we are saying that the first position, right, which is the one, and then on a grid of 2 rows, and then 3 columns, right? So if we take this, we are seeing that we have 3 columns, which is 1, right? 1 with the bar graph, 1 with the scatter plot, and then 1 with the line graph, right? As a 3 column. That's what the argument is actually doing, right? And it's just one row. The first one is also showing that it's just one row. Then the last one is showing that at the first position, we have 3 columns, and then it's having only one row. So what it's showing is that there could be a graph, a subplot, which will not be just a single row like this, where we have only 1, 2, 3, but there could be another graph beneath this one, right? Maybe another 3, and then another 3, then another 3, right? But this one, we have only one row, which is having 3 subplots. All right, that's what this one is doing. So if you see the second subplot also, see the second subplot, we have second position. It is being placed at the second position, which is this dot graph that we have here, scatter plot that we have here, right? And it's still 3 columns, and then we have 1 row. Same thing happens to the third one, the last one, where we have the third position, and then 3 columns and 1 row. All right, that's all we are doing here. Okay, and then each one of them, we are putting these names and then score, right? Each one of them, we are putting the names and the score there. So the names becomes the represented on the x-axis, right? And then the scores over on the y-axis. Okay, and you can actually give a main title to all of them, which you use the subtitle to do that, right? So on the subtitle, we've put categorical plotting, and you can see it up here that we have categorical plotting over here. All right, that's what this subtitle is also doing. However, you can also give individual titles, and you can also give an X label and then X label and then Y label respectively to each of these subplots. All right. So let's move on to Seaborn, actually. So what we're doing so far is matplotlib, right? We're just using the matplotlib to plot all these ones, right? Sometimes it becomes difficult to use the matplotlib due to its complexity, but with Seaborn, we'll be able to manipulate the graph in such a way that we want. It helps us to actually plot it in a way that we want to plot it. And sometimes it's difficult to use the matplotlib to visualize data frames. It becomes a bit complex when we want to visualize a data frame. But with a Seaborn, you can actually do it like that, right? So let's move on to Seaborn. Someone is asking of fixed size. I hope by now you get it right. If it's still not clear, drop it the message again. Let me go through again. Okay, so let's talk about the Seaborn. Okay, I should repeat this fixed size. Okay, so let's go up here a bit. Okay, what I said about the fixed size is that it's just the figure size, right? The size of this figure that we are showing. So if you see this one, we have 3 plots here, right? If it's one plot like this, then down here we'll have its own length, and then the width will also have its own width. But with this one, we are specifying that the length down here should be 20, and then the width, which is the vertical part, should be 10, right? So let me just change this one so that you see it. Let me just say, instead of 20, let me make it 10, right? And then instead of 10 here, let me make it 5. All right, then let's run this and then we'll see the output. Now you see how the figure size has been. See, the figure size has become very small, right? And if you see the x-axis, all the x-axis numbers have been cramped together. You cannot even read the class 1, class 2, up to class 7. That's why we made it a little big so that we can see, right? So the fixed size is just the figure size, just manipulating the size of the figure, right? We can also go extreme. Maybe instead of 20, let's make it 30, right? Let's go to 30 and see 30, and then let's say 15, right? Let's plot. Now you see that this one has become bigger, right? It's become way bigger. Now you can see the X as is very clear. The class 1 to class 7, you can see it very clearly. All right. I hope it's clear now. Okay, so let's move on to Seaborn. So as I was saying, sometimes we can difficult manipulating the matplotlib, and with Seaborn is easy to do. It's easier to do it, and it helps you to actually plot the graph the way you want to plot it, and help you to manipulate it and visualize it very well. All right. So the same way as we imported the matplotlib, right? With every library, in order to use it, you have to import it. Okay, so the same way we are going to import Seaborn. Okay, so we import Seaborn as SNS. So as I always keep on saying that we don't want to be typing Seaborn over and over again. So we just shorten it to SNS, right? So this SNS can be just maybe A. You can just represent it with A, or can just represent it with your name, Sanjay, right? And it will work, right? Because this is just a name you're giving, just an alias, or just another name you are just giving. All right. In order to just recognize it everywhere, we just use SNS to represent Seaborn, right? So let's import this. And then after that, we are going to use this data set, right? I'll give you this data set. If you get the notebook, you can also run it, right? This Pokemon data set is an SL format, right? It's an SL format. If you remember the pandas class, we were using read underscore CSV, right? But this one is in an SL format, XLS. So we are using read underscore SL, right, to load this data set. All right, then after loading it, we will put it in our data, which is a variable that we are creating. Okay, so if we run this, now we've loaded our data successfully. Let's just see the first 5 rows of this. All right, so this is our data. This is our data we have here. This is the data we have where we have some name, we have type 1, type 2, total HP, attack, defense, ATK, DF, speed, stage, legendary. Yeah, these are the columns that we have. If we see all the data set, let me just clean the head and see everything here. You see that it's over here, right? We have 151 rows and then 12 columns. All right. So this is everything that we have here. So let me just see only the first 5, right? By using the head function, see only the first 5 rows. Okay. So now we are going to use this one to perform further visualization. So, sorry. Now what we can do is to use this LM plot, right? We can use this LM plot to actually plot it when we want to plot a linear relationship, right, between 2 variables. We can use this LM plot to do that. So I've given you what the LM plot function does over here. I've given you the what it actually does over here. So when you get access to the notebook, you can actually read that. So we want to actually see the linear relationship between this attack and then defense, all right? So in that case, we are going to use the LM plot, okay? So if we do this, this is what we have here, all right? Now you see how the Seaborn is very nice, right? Very nice here, all right? And then we have our attack and then defense over here, right? Being named for us. This one, we did not even bother ourselves using the X label and the Y label to name it manually. It's already there for us, all right? And we also have the line of best fit being drawn for us, all right? Being drawn for us. And you can see how the relationship is, whether it's positively correlated or it's negatively correlated or there's no correlation or I mean, you can just visualize it and have a fair idea about attack and then defense, right? You can visualize it and see how both of them are related, all right? So this is an image I've put here for you. This is an image I've put here for you. Let me try and minimize it. Okay, so if you visualize it and you want to get more insight whether they are positively correlated or negatively correlated or there's no correlation, you can see it from, you can use this image to compare to it, right? So if you see it like this, it's more strong positive correlation, right? It's having strong positive correlation. And if it is more scattered bestow like this, then you can see that it's moderate positive correlation. And if you can see it just scattered like this with no direction, it's not going up or it's not coming down, then you can see that there's no correlation between them, all right? And if it's slanted down like this, then you can see that it's a negative correlation, but the correlation is not as strong, right? But if you see the one next to it, you can see that it's strong. It's negative, but the correlation is strong, all right? And then the curvilinear relationship, you can also visualize that. So I've put this image for you for comparison purpose. All right. So in another plot, you can also off this best fit line. All right. This best fit line comes automatically. If you don't do anything to it, it will just come, right? And it's a good thing if you want to see how the correlation is and measure the residuals. I mean, when we talk about the statistics part, we will know what the residuals are. Which best fit line is good for us to actually um, measure the residuals, right? But if you want to turn that thing up, you can also do that by setting the fit reg to false, right? So another argument that you can give is the fit reg, and then you turn it to false, all right? So let me put this one here so that you can see it very well. All right, so we have x equals attack, which is the x on the x-axis. We have attack there. On the y-axis, we have defense. All right, we have defense there. And then this is our data, right? The data equals our data. And then we have our fit reg equals false, right? Fit reg equals false. Just to put the line of best fits, just off the line of best fit, right? And then we are using hue equals stage. You know, if you see this first one, right? If you see this plot that we have here, this is a two-dimensional plot, all right? So this is two variables that we are visualizing. But if you want to visualize three variables, it's impossible to do it on a two-dimension, right? That is what hue comes in. Hue helps you to visualize three variables in a two-dimensional space, all right? So if you see the output here, although we have attack and then defensive, but hue will help us to have another variable, right? To visualize another variable. So if you set hue to be equal to another variable, then you can be able to visualize three variables in the two-dimensional space. All right, so if you can see the colors here, we have this blue and then the green and then whatever this color you can talk about, orange, something like that. All right, so we have three variables that we've been able to visualize them. Okay, instead of doing it in the two-dimensional space like this with only two variables, we've been able to visualize three variables here with with the help of hue. Okay, and we've also turned the fit, the line of best fit off by setting the fit reg equals false. All right, so this one is not having any line of best fit, but this one is having it. Okay, so there's two things here that you can take. I mean, two takeaways here: fit reg equals false, and then hue equals another variable, helping you to visualize three variables in a two-dimensional space. Okay, I've given you notes over there so that just in case you forget, you can just read the notes. So if you get access to the notebook, you can revise that. All right. So let's move on to this part also. So this is another way that we can use the Seaborn in combination with the Matplotlib to do visualization. So if you see here, we're using PLT again, right? PLT was for Seaborn, right? I mean, for Matplotlib, we imported matplotlib.pyplot as PLT. So if you see this part, I mute. Okay, fine. Dr. Mohammed, yeah, Dr. Mohammed. I mute, then you mute yourself, but I have feedback from your side a lot. All right. I have feedback from your side a lot, so please mute yourself for me. All right, thank you. So as I was saying, that we loaded our library, which is matplotlib, right? Matplotlib .pyplot as PLT. So if you see down here, just as this simple plot that we want to do, you can see a lot of things here. plt.y ylim, plt.xlim, right? plt.xlabel, plt.ylabel. I mean, unlike the Seaborn that we like the Seaborn that we just plot without doing all those labels, but we still have the labels there, right? It's the matplotlib is quite complex sometimes if you want to actually do it, right? What is fitreg? Fitreg is just for whether turning off the line of best fit or turning on the line of best fit, right? So if you see this one, we did not set fit reg to anything, right? So by default, it is set to true. Okay, that's why we have this line. We have this line here. All right, that's why we have this line here. So if you go to this part, we now say that we don't want to see that line. That's why we set it to false. So that's what fit reg is doing, right? We are just fitting the regression line, right? Whether you want to fit the regression line or you don't want to fit the regression line. All right, so you can turn it off and on. Okay, I hope it's clear. So if you see this one, it's not having it because we've turned it off. Okay. The line, as I said, you use the line to actually determine the residuals. We've not done the status part of that, so we will do it and then you get to understand it, right? You get to understand it. Like if you see some of the points are lying on the line, right? Some of the points are lying on the line, whilst others are not lying on the line. But if you want to actually measure the residuals, which is the error, right? You measure the difference between each point and then the line, then you can see the error that you are having, right? Let's say you are predicting whether someone will take a loan or someone will not take a loan, right? And if you see the points that are on the line have been predicted correctly, right? But the points that are not on the line, right? It's just an estimated plotting. So if you want to see the mistake you did whilst plotting this, right, then you have to measure the distance between each point and the line, right? And then you get it. When we do the statistics part of it, you'll get to understand how residuals are very important, right? And how this line is very important. All right, so let's not deviate from this. We will do that one in the statistics class and you'll get to understand it better. Okay. So let's move on to what we can do for the next one. Okay, so we can also use box plot to also visualize it. We can use box plot to actually visualize our data. So if you see this part, right, this is here we are using Seaborn. So you can see how simple it is, right? We are using Seaborn, and then as we talk about the fixed size, right, we are saying 15 by 15, so more like a box, right? 15 for the vertical part, the horizontal part, and then 15 for the vertical part, right? That's the size of it. That's what this plt.fixed size is doing, right? And then we are using the Seaborn, which is the SNS here, right? To plot a box plot, right? Plot a box plot, and then our data equals, data equals our data, which we have already stored all our data inside in that variable, all right? So these are all the variables that we have, right? These are all the variables that we have. If I should show you this, let me just show you this here. Let me just show you what is inside our data. Let me just show you the first, no, small. Okay, now if you see our data here, right? If you see our data here, we are having name, type 1, type 2, total, HP, attack, defense, ATK, DEF, speed, stage, legendary, right? This is what we have been able to plot on a box plot. We have used box plot to plot each of these variables that we have, right? Each of these columns that we have here. we've been able to plot them here, right? So you can see total, HP, attack, defense, ATK, DF, speed, stage, legendary. We've been able to plot all of them, all right? That's what we are doing. We are using the box plot to do that, all right? So let's move on and see what we can do here again. Now, if you see this part, right? If you see the plot that we did, if you see the plot that we did, this total, right? If you see the total column, if you see how the box plot has been laid down here, right? If you see the total column, the total is just the summation of all these, right? This total 318 is just a summation of these. 405 is just a summation of this rule. So we don't need to actually plot the total part. That's why the total part is looking weird, right? And if you see this part, if you see the stage, if you see how the stage has been plotted and the legendary, the stage is actually the number of the stage column is having 1, 2, which, the numbers here are very, very low compared to the others. 45, 49, 49, 65, 65, 45, 1, right? Is very, very low. That's why you see it so ugly here like that. All right. So it's quite uncomfortable to actually plot them together with the other variables. All right. So what we are going to do is to drop that part. We are going to drop the total and then we'll drop these two. All right. Then we visualize the rest. Okay. We will drop these two and then we visualize the rest. Right. So that's what this part is doing. So we are saying that in our data, we are dropping total, and then we will drop legendary, then we will drop stage. Okay, we're going to drop this part, this total, which is looking weird here, and these two, this stage and then legendary, right? We are going to drop them too, and then we will visualize the rest. Okay, then after that, after dropping everything, right, we are using the drop function. If you remember last class in pandas, we used drop, right? To drop the columns, we use the drop function, right? And then we store them in our data, right? Our data one. Now, our original data is stored in our data, right? Now we are going to store them in our data one, right? It's just a variable name that we are choosing, okay? So we will drop these columns. We will drop these columns, total, legendary, stage. We'll drop them. And then we are saying that axis equals 1. This one you have to take note of it, right? This is showing that what we want to drop is located in the column. All right, axis equals 1 is showing that what we want to drop is in the column. If we use axis equals 0, then you are telling it, you are telling the, Python, you are telling the Python code that this, what you want to drop is in the row, which is not true, right? It's in the column. That's why we use 1, okay? And then after that, we visualize the first 5 rows. We use the dot head to visualize the first 5 rows, okay? So is this part clear? Is there any explanation more that you need? Total parts. Okay, what I'm saying is that if you see this data that we loaded, the total here, right? The total here, this total is just a summation of HP, which is having 45, just a summation of 45, 49, 49, 65, 65, 41, 1, right? Just a summation of all these that is summing up, giving us the total of 318. And then the total of all these, right? The total of all these is giving us 405. The total of all these here, total of all these here, right? Up to 80 is giving us 525. So we don't need to plot the total. It's not necessary for us to visualize the total parts, all right? That's why we want to drop it so that we can have a better look at the rest, right? If you see how the box plot has been plotted, right? The total part is looking weird among all of them. See where it is? Because it is having highest numbers and it's affecting the vertical indexes here, right? It's affected it because see, it is going all the way to 700. But if we see the other entries here, the other data points, the highest here is the highest here is 100, right? But it's going all the way to 700. It is affecting everything, right? Because of the total column, having huge values, right? The same way, if you see the stage part, right, it's having very, very low, right? Having very, 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 very low. That's why you can see it here being ugly like that, right? And the legendary part is just a Boolean entry, which is here, whether it's true or false, and we don't need to actually bother ourselves with that one. That's why we are dropping that. We are dropping the total, we are dropping the legendary, then we drop the stage, right? So we drop these three, the total, the stage, and then the legendary. That's what we are doing over here, okay? So after that, now we can visualize the rest. I mean, we drop and then we stored our data, our new data in our data one, right? So now we are going to use Seaborn again to plot it, to plot another box plot, all right? So if we plot this, let's see what we have here. Now you see that these ones are being visualized very well, right? Unlike this where some is up there, some is down there. I mean, it's just scattered everywhere. But if you see this one, you can actually see them and compare them, right? You can actually have a better insight with this kind of data, right? With this kind of plots. Okay. So we can also check, I mean, the correlation between the variables, right? So to do that, if you remember in our previous classes, we use call, right? We use call to check for the correlation that exists between them, all right? And then we store this in call, right? So let's just run this and see this, the output we have. Now, let's just keep an eye on the diagonals. Let me see if I can get a pen here. All right, so let's just keep an eye on the diagonals, right? We can see that HP and HP is having one, right? Like every variable and itself is having a one, I mean correlation of one, right? That's what is going to happen. With all the diagonals, we have one here, 0.1, I mean 1.000, 1.000, 1.000, 1.000, right? So all the diagonals are going to have that. Okay, all the diagonals are going to have that because it's just comparing it with itself. HP, attack, and then attack, right? We'll have this, and then defense, right? We'll have this, right? There's a correlation for itself, and then ATK, and then ATK. We'll have correlation of one of itself, and then DF, and then DF. We'll have a correlation of one for itself. Speed, and then speed. We'll have a correlation of one, right? Now that's unnecessary to us. What we want to actually compare is compare one compare one variable with the other, right? For instance, let's take HP and then attack. Is there any correlation between the HP stands for horsepower, right? Stands for the car's horsepower. So if we check HP and then attack, right? We check the HP and then the attack, right? You can see that it's having 0.3. Okay, 0.3, which is a bit low. It's positive correlated, but it's a bit low. If you see the image I gave you here, right, is positively correlated. It's like this, right? Moderate positive correlation. All right, is very low. 0.3 is very, very low. All right, so it's like the influence that one is having on the other is very, very less, right? And if you see all of them, I think all of them are having very, 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 very low, right? Where if you see the numbers, some are even negatively correlated. If you see HP and speed, right, it's negative 0.04, which is very, very, very low, right? Very, very, very low. If you see, let's see, this is 0.4, a bit high, but still, I mean, low, right? Positively correlated, but still low. Okay, and then if you see DF and then attack, I think this one is a bit better, right? There's a bit correlation between DF and then attack. All right, that one is 0.5, but it's still low. It's still low, but it's compared to others, it's a bit better. The others are having negative. If you see speed and defense here, speed and defense negative 0.05, which is very, very, I mean, low negative correlation. Okay, we can also visualize this. We can also visualize this correlation, right? So if we use this heat map, right? If we use this heat map, we can also visualize it. Can visualize it. And this is, I mean, simple. If you see, just see the bar over here, the bar at the right side. You see the bar at the right side, right? The bar at the right side. It's starting from 0 all the way to 1, right? From 0 all the way to 1, right? And what it's saying is that one is 0, which means that the correlation between is very low. Is very low, right? So from 0, the negative is actually not coming, but from 0 goes to -1, -2, -3, right? Is very low. And then as it goes up, as the color becomes lighter, then the correlation between them becomes higher, right? So if the color is very deep, is very dark, then there's a low correlation. But if the color is very light, then there's a higher correlation, right? So if you see the correlation between themselves, I mean the variable and itself, right? Like HP and HP is 1. I mean the highest correlation you can have is 1, right? So this is highest, right? HP and HP. So it's supposed to be very light. If you see the bar, if it is 1, then it's, I mean the correlation between is very high, right? So let's see HP and then HP, right? If you see HP here, right? And then you see HP here, HP and HP, they meet here. That's why you see it very white, right? Now, if you see the diagonals here, the diagonals are all white like that, right? All white or all light, right? Show you that they are just like we did over here. All the diagonals are having 1, 1, 1, 1, 1, 1, right? That is the highest correlation they can have. That's why you can see from the heat map that the diagonals are all white, right? But if you see speed and HP is very, very low. Speed and HP, right? It's dark. If you see the bar, the darker it is, the less correlated it is. So if we see here, right, speed and HP, negative 0.04, right? So it's supposed to be very dark, right? Let's see the one which was 0.5, which was a little better, right? Which is DF and then ATK. It's a bit better, right? So it's supposed to actually be, let's see the bar where 0.5 will be. 0.5 is between this 0.4 and 0.6, right? So it's supposed to be a bit red, right? A bit red. So let's go and see DF and then is DF and then ATK, all right? DF and ATK. So if you see DF and then ATK, you see that it's a bit red, right? It's a bit red over here, right? It's supposed to lie between 0.4 and 0.6, which is a bit red here. So if you see it here, right? 0.5 is over here, all right? So the diagonals will be white, and then you can compare, have a bit insight about the rest of the correlation. Now, what we're doing so far is compare one variable with the other. But what if you want to just visualize just one, right? You just want to have a distribution of just one variable and see how that variable is being distributed, right? When we talk about the statistics class, we talk about normal distribution, and we get a better understanding of that. But for this visualization, I've put this image here for you so that you can at least have a fair idea, right? If it's like this, then it's symmetric, right? It's like the total area under this. If you see the middle one, right? The middle one, we are having 3 graphs here, right? We're having one on the left, one on the right, and then one in the middle. If you see the middle one is a bit symmetric, right? It's a bit symmetric, meaning that the left half is equal to the right half, right? And the mean, the median, and the mode are all the same, right? There's no skewness, right? It's not tilt to the left or tilt to the right, all right? But if you see the one on the right, right, it is positively skewed, right? Meaning that it is having less, it's actually skewed to the, positively skewed, right? The left tail, right? The left tail is more symmetric, but if you see the right tail, it's more skewed, right? It's more skewed, okay? But if you see the one on the left tail is more skewed, but the right one is a bit symmetric, okay? So if you want to see the distribution of just one variable, right, we can also do that. So if we see, let's say we want to see the distribution of just the defense part, right, just the defense column. Let me just put this data here so that we can actually see. Let me just put this data here. And then let's see only the head part, all right? Yeah. So let's just say we want to just see how this defense part is distributed, right? We are having 49, 63, 83, 40, 43, 58, all the way down, right? Let's see how it is being distributed, right? Let's see how this is being distributed. So we want just this part, and then what we are using is the dist plot, right? We are using the dist plot to do this, and then as we talked earlier on, we're using the SNS standing for seaborne, right? So for seaborne, it's just one line of code, unlike the matplotlib that you need to do a lot of stuff. But this one is just one line of code, then you get it. All right. So we're using sns.distplot, right? And then we want to visualize the defense part. We want to see how it is being distributed. So if we run this, let's see what we have. All right. This is what we have here. Now, if you see the distribution and you compare to the image that we have here, right, you can see that it is it is positively skewed, right? The right tail is a bit skewed, right? And this part is a bit symmetric, right? It's positively skewed, right? So it gives you a better idea of how that column, this defense column is distributed, all right? So you can do that for all the other columns, right? And do that for all the other columns and have a better idea of it. Now, if you see this, right, we have one smooth line, and then we have one smooth line, and then a histogram, all right? One smooth line and then a histogram being put together. You can just plot one of them, but if you use this plot, by default, it gives you this, right? The smooth line is actually just a KDE, right? I've given explanation of KDE over here, just kernel density estimate. And we talk about that one also in the statistics part, but I've given you links here that you can just read about the KDE. It's not anything big. I've given you a link here that you can just read about the KDE, all right? Next week, we start the statistics, so it's not anything, but we don't need to divert from this. Let's concentrate on this one. We will do that in the stats class. So it has put this smooth line, which is the KD, and then the histogram together. But we can actually plot just one of them, right? Let's say we want to just plot. No, we don't want this one. Okay, this is a box plot that actually confirms the distribution of that. If you see the box plot, is just shift to the left like that, just confirming what we did over here. All right, so we can actually turn off, as we did for this for you, yeah, as we did for this one, right? As we did for this, we turn off the line of best fit. The same way we can turn off the smooth line, right? The KDE, we can turn it off, right? So if we set KDE equals false, then we turn that off. And this is the graph we have. We have only the histogram. We don't have the histogram together with the KDE or together with the smooth line. Okay, you can actually turn it off by using the KDE equals false. Okay. Now, if we plot this one, right, we can also plot only the smooth line or the KDE, right? We can only plot that one by using the KDE plot. Right? If we use the KDE plot, we can also have access to plot only the KDE and not the KDE with the histogram, right? We can also have access to that. And we can actually fill this part. We can actually fill this part to have a better view of that. We can actually fill this part, right? By setting shade equals true. If you set shade equals true, then you fill that part, right? So if you run that, you can see here, right? That's and that here has been shaded correctly for you. Now you have a better view of it. Okay, you have a better view of it. We can also use joint plot, right? We've been visualizing only one variable here, right? Let's say we want to do for two variables. We can use joint plot to do that, right? We can use joint plot to do that. So we are going to do this for two columns here, defense and then attack, right? We're going to do that for defense and then attack. Instead of only defense, now we are going to do for defense and attack. Previously, we've been doing for only defense, right? So we can do for two variables also, right? That's a bivariate distribution. We can also visualize two variables, okay? So if we do that, we use the joint plot to do that, okay? We use the joint plot to do that. And if we run that, we see the graph that we have, beautiful one here, right? Where we have a histogram for the defense, right? For the defense column, we have a histogram, okay? For the defense column, we have a histogram above here. For the attack, we have a histogram at the right side. And then we see a scatter plot being plotted in between them to visualize the correlation between attack and defense. We have a scatter plot also here. So you can see individual distributions and you can see a correlation between in the two, all right? And we use the joint plot for this purpose, okay? We use the joint plot for this purpose. Now, if you see this one, if you see the correlation between these two, right? Between defense and attack is 0.491965. It's not that strong, but it's positively correlated. That's why we see this one here, right? That's why we see it like this. If we see the image that I showed you up here, let's go up here. Yeah, if you see this one, right, it's positively correlated, but it's not that strong. It's a moderate positive correlation, right? 0.4 is very low, all right? That's why you have this one here, all the way down, yeah. That's why you have this one here, okay? That's why you have this one here. Okay, so if you see this one, by default is giving us this histogram, right? By default is giving us this histogram, but we can actually manipulate. I mean, do it in such a way that it will give us what we want instead of giving us the default one. We can actually manipulate it and get what we want. So in order to do that, we will manipulate the kind, right? There's another argument called kind, right? So in this, if you see the first one, we did our data one, and then the two variables there, but we did not actually put any other, parameter, right? But now we are putting another parameter here, which is kind. Kind equals KDE, all right? Now we want KDE. If you see KDE here, right? This is KDE. This is a kind of a KDE, right? So if we do KDE, right? If we do KD equals, kind equals KD, right? Then we will have it this way. See the plot now we have, right? Instead of giving us this default histogram, giving us histogram for defense and then giving us histogram for attack. Now we are having KD, for defense and then KD for attack, right? Giving us this smooth one to also have a better distribution view. All right, have a better view of our distribution. Okay, so we can also let me clean this part. Yeah, we can also change the kind. The kind is, we have different kinds. I've put it up here for you. We have kind equals scatter. You can use scatter. You can use reg. You can use reset. You can use KD. You can use hex, right, for hexagon. You can just play with it, right? Just be changing this kind, and then you see the kind of plot that you'll be having, right? If we change this kind, instead of KD, we change it to reg, right? That's what we have. Change it to reg. You see that's now we have a regression, right? Having a regression line as we plotted earlier here, right? Let me just go up here and then see. Yeah, this is what we have here. This is the same thing that we are having here. The same thing that we are plotting over here, right? By certain kind equals reg, we have this, and then we have our histogram together with the KDE or together with the smooth line, all right? So it's just a manipulation of this kind. It's a manipulation of this this argument called kind, okay? Now let's see visualization more than two. Now we are doing two, which is attack and defense. Now we are going to add another one, right? HP. We are going to add another one. So we are not now limiting, we are making it more complex and complex, right? So from defense and attack, we are adding another column called HP, right? If you see our data here, we have HP also here, right? So now we are picking 3 instead of 2. Defense, attack, and then HP. Okay. So now if we go down here, all the way down here, and then we run the 3, this is what we have now, right? This is what we have now. So instead of just plotting the 2 for joint plot to have, to visualize just the 2, we can actually visualize more than 2, right? By using the pair plot, right? We use pair plot to do this, right? And we are seeing that the kind equals scatter, right? Just a scatter plot that we have over here, right? So you can just be playing with the kind to have different kind of visualization over here. Okay, but to visualize more than 2, more than 2, 3, 4, 5, just use plots. Pair plots, all right? And we're using Seaborn, which is SNS, right? Just one line of code. Unlike the matplotlib, if you see this code that we put here, right? We see this one, just this line, see the code that we wrote over here, a lot of them, right? A lot of them. But if you see this one, we see this one, all this graph, all this one, we just use just one line, right? That's the power of Seaborn, right? And Seaborn is actually built on top of matplotlib, all right? Now we are changing the kind, right? Now we are going to use the same pair plots, right? Plotting the same 3 columns, but now we are using kind equals scatter, but the diagonal, if you see the diagonals here, right? This is a histogram. We're having histogram, right? We want to manipulate the diagonal. So we are bringing another parameter. We are bringing in another parameter called diag_kind, right? So the kind of the diagonal, what kind of the diagonal do we want? We want KDE, all right? 1 KDE. So if we run this, we have this, right? Now we're having the KDE at the diagonals, right? To visualize it very well. Of the KDEs at the diagonals, right? Instead of having this histogram, we want the KDE, all right? So if we use this diag kind, right, diag_kind, right, to show the kind of diagonal that we want, then this give us this smooth graph here, all right? Give us this smooth graph that we have here. Now, if we see our data here, right? If we see our data here, there are some of them which are categorical actually, right? Like this part, which is true or false, right? We can also plot that part. Earlier on, we dropped that part, where we can actually plot that part. We are going to use a different data set, different data set to do that. If you remember this automobile .csv, we actually used it last week for our pandas class. We are going to use the same thing for this one. And this part now, you can see that this is stored in a CSV format, comma separated values, right? All right, so it's automobile.csv, all right, .csv here. That's why we're using read_CSV. If you see the first one that we read over here, the data that we read over here, all right, you see the data that we read over here, all the way down here, yeah. It's read_SL because it was stored in XLS, in form of an SL, right? It was a form of an SL. But this one that we are going to use right now is in form of comma separated values, right? It's a CSV format, right? That's why we are using read_CSV, right? And then we want it to be in a data frame, right? That's why we're using PD, which is pandas, right? We shortened pandas. When we imported the pandas, we shortened it to PD. Otherwise, we should have written pandas here, right? But we don't want to be, keeping on writing pandas over and over. So we just shorten it to PD, all right? So let's read this data, and then we store it in our variable called data, right? Now, if we see the head of it, this is what we have over here. This is the data that we have. All right, if you see the head of it, this is the data we have. We actually did a lot with this data last week. If you see here, we have symboling, we have normalized losses, we have the make, we have the fuel type, we have the aspiration, number of doors, body style, drive, wheels, engine location, wheelbase, all the way to the last column, which is price. All right, all the way to the last column, which is price. Okay, which is price. Now we are just seeing the first 5 rows. Actually, if we see the length of this, if we see the length of this data set, right, by using the len, we use this one to see the length of this data set. We have it 201 rows, right, which is a lot of not that much compared to other data sets, but it's still a lot to just display everything, right? So we're just going to use just the head to see this, just the first 5 rows, right? Now, what we can do here, right? What we can do here is to visualize the number of those. If we see the number of those column here, right? Number of those. If you keep your eye here, number of those here, right? Number of those here. It's a categorical variable here. It's either 2 or it's 4, right? Whether it's the car is having 2 doors or the car is having 4 doors, right? Whether the car is having 2 doors or it's having 4 doors, right? So number of doors is either 2 doors or 4 doors, right? So we want to see is there any relationship between the number of doors that a car is having and its horsepower, right? So in doing so, we are using another one which is called strip plot, right? Strip plots. And as I said, Seaborn, just one line of code and it's done, right? SNS dot strip plots. Okay, SNS dot strip plots. And then in our data, we are just selecting the number of doors. And then in our data, we want to select the horsepower, right? Then if we use that strip plot, we have this output. We have this output. Now, if you can see here, right, on the x-axis we have the number of doors, on the y-axis we have the horsepower. All right, on the y-axis we have the horsepower. Now, if you watch it carefully, you can see that two doors are having higher horsepower as compared to 4 doors, right? The 2 doors are having higher horsepower as compared to 4 doors, right? So this one just give you a quick idea about the relationship between the number of doors and the horsepower that the car is having. All right, just give you a quick idea about how it is. We can also use the box plot to actually confirm that, right? Now, if you use the box plot, you can see what we have here. That this one is having higher horsepower as compared to the 4 doors, right? The box plots can also confirm that for us. All right. If you see the minimum here, the maximum here with some outlier there, right? We can also use the bar plots. If we use the bar plots, to confirm it, right? You can also use the bar plot to confirm it, and you can see it from here. You see their heights. That's the car with the 2 door is having higher horsepower as compared to the car with the 4, doors. All right. It's up to now clear. Is there anything you want me to clear? Is it clear up to now? Is there anything that you want me to go over? Guys, are we there? If it's clear, let me see in the chat box. If there's any question you want to put, let me see it in the chat box. All right, so All right, guys. I think we will end it here. If there's no question, we will end it here, and then we will meet next week. So just be ready for your final project, and then final project for your certificate and all the assignments. Please do well to submit them. All right. So thank you for the evening, and good night.